In the winter of 1626, a Jesuit missionary stepped into a Chinese farmhouse in the frozen north and stopped in disbelief. Outside, the temperature had plunged to -50 Celsius. Inside, without a single fireplace, without central heating, without electricity, a family sat comfortably in their cotton robes, warm enough to sleep through the night. He wrote in his journal that it defied everything he knew about survival. If you think modern insulation is advanced, hit subscribe, because what you're about to discover will make you question why we ever abandoned these methods. Today, you're going to uncover the hidden engineering genius of ancient China, where peasants and emperors alike survived in climates that would shut down modern cities. We're counting down the most ingenious thermal inventions ever created, from architectural tricks that trapped heat for 16 hours straight, to materials so effective that NASA scientists are studying them today. And number one on this list? It's a system so brilliant, so counterintuitive, that when Western engineers finally understood it, they couldn't believe it had been hiding in plain sight for 2,000 years. 10. The magic of rammed earth walls. Imagine standing before a wall 3 feet thick, built entirely without bricks or mortar. You press your hand against it in the dead of winter, and it feels almost neutral, neither cold nor warm. This is rammed earth, and it was the silent guardian of ancient Chinese homes. Workers would pound moistened yellow earth layer by layer into wooden frames until the walls became solid as stone. But here's the invisible genius. That thickness wasn't just for strength. Rammed earth has a thermal mass so high that it absorbs heat during the day and releases it slowly through the night. In regions where temperatures swung 40 degrees between noon and midnight, these walls smoothed out the extremes, keeping interiors stable. Modern concrete walls conduct cold rapidly. Rammed earth resists it. The twist? When archaeologists measured surviving rammed earth structures from the Han Dynasty, they found the interior temperature varied by only 6 degrees across an entire winter day, despite no active heating. We traded thermal intelligence for construction speed. 9. The courtyard trap picture. A home shaped like a square donut, with rooms wrapping around a central open courtyard. It sounds counterintuitive, doesn't it? Why would you invite the cold into the center of your house? But ancient Chinese architects understood something about airflow that wouldn't be mathematically proven until the 20th century. The courtyard acted as a thermal buffer zone. Cold air sank into the open center, while the surrounding rooms, shielded by multiple walls, stayed insulated. During the day, the courtyard absorbed sunlight, heating the air. At night, the heavy cold air stayed low, and the warm air trapped in the rooms remained stratified above it. This is called thermal stratification, and it's the same principle used in modern passive house design. But here's where it gets brilliant. The courtyard also controlled humidity. In northern China, dry winter air cracks wooden furniture and irritates lungs. The open courtyard allowed residents to place water basins in the center, humidifying the air naturally without dampening the walls. European homes of the same era had no such system. They were drafty, moldy, or bone dry. The Chinese courtyard was a climate control system disguised as architecture. 8. Lattice windows with paper skin. Now, imagine you're inside that courtyard home and you look toward the window. But it's not glass. It's a wooden lattice frame covered in sheets of oiled paper. You're thinking, paper? In winter? That sounds like a recipe for freezing. But this wasn't ordinary paper. It was yuan paper, made from mulberry bark and rice paste, then treated with tung oil until it became translucent and water-resistant. The lattice provided structural support, while the paper acted as a flexible, breathable membrane. Here's the counterintuitive part. Glass, which we think of as superior, conducts heat 25 times faster than oiled paper. Glass windows radiate cold into a room. Paper windows insulate it. And because the paper was slightly porous, it allowed moisture to escape without creating condensation, preventing mold and rot. European homes with glass windows were colder and damper. But the true genius reveals itself in summer. When the heat became unbearable, residents simply replaced the paper with thin silk gauze, transforming the window into a ventilation screen. One frame, two climate solutions. We call that smart design today. They called it common sense 1,000 years ago. 7. The elevated floor platforms step inside an ancient northern Chinese home, and you'd immediately notice something odd. The floor isn't level with the ground. It's raised sometimes by a foot, sometimes by 3, sitting on a platform of compacted earth and stone. Why? Because cold air is heavy. It sinks. And in a home built directly on frozen ground, that cold seeps upward through conduction, chilling everything it touches. The raised platform, called a diaojiao, broke that connection. The air gap beneath acted as an insulation layer, and the thermal mass of the platform itself absorbed daytime heat, releasing it slowly after dark. But here's the hidden brilliance. That gap wasn't wasted space. It was used for storage, keeping root vegetables cool without freezing them. Because the temperature under the platform stayed just above freezing even when the outside air dropped to -40. Modern homes use concrete slabs poured directly on grade, which require expensive underfloor insulation to achieve the same effect. The ancient Chinese did it with dirt and air. And there's one more twist. In homes that use the heated floor system we'll discuss later, the platform wasn't hollow. It was honeycombed with channels, transforming the entire floor into a radiant heating panel. The platform wasn't just insulation, it was infrastructure. But walls and platforms could only do so much. The real secret to surviving -50 degrees wasn't about keeping the cold out. It was about generating heat and distributing it so efficiently that a single fire could warm an entire home for 16 hours. What comes next isn't just clever, it's revolutionary. 6. The Kang, the heated bed platform. Imagine this. You wake up in the middle of a brutal northern winter, and instead of shivering under piles of blankets, you're lying on a surface that radiates gentle, even warmth from beneath your body. This is the Kang, and it was the most ingenious piece of furniture ever invented. From the outside, it looks like a raised brick platform covered with mats, taking up a quarter or even half of the room. But inside, it's a maze. Hollow channels snake through the structure, and those channels are connected to the home's cooking stove in the adjacent room. Every time the family cooked a meal, hot smoke and gases from the fire traveled through the Kang's internal passages before exiting through a chimney. The brick absorbed that heat and radiated it for hours after the fire died. One cooking session in the morning could keep the Kang warm until midnight. Families ate on it, worked on it, slept on it. In the coldest months, entire households gathered on the Kang, using it as a communal heat source. Here's why it was revolutionary. It required no extra fuel. The same fire that cooked food also heated the home. Compare that to a European fireplace, where 90% of the heat escapes up the chimney, or a modern space heater that runs on electricity. The Kang had an efficiency rate that wouldn't be matched until the invention of radiant floor heating in the 20th century. But there's a darker side to this story. Prolonged exposure to the Kang's heat caused a medical condition called Kang cancer, a type of skin cancer from chronic low-level burns. It was a trade-off, warmth or risk. For people facing death by freezing, the choice was obvious. 5. The flue system. Engineering smoke. Now let's go deeper into the engineering. The Kang didn't work by accident. It required precise construction, and the key was the flue system. The channels inside the Kang weren't random. They were designed with a slight upward incline, using gravity and convection to pull smoke through the entire structure. The entry point near the stove was lower than the exit point at the chimney, creating a natural draft. If the incline was too steep, the smoke rushed through too quickly, and the Kang didn't absorb enough heat. If it was too shallow, the smoke stagnated, and the room filled with carbon monoxide. Builders had to calculate the angle by intuition and experience, adjusting based on the stove size and the Kang's length. But here's the hidden brilliance. The flue system was modular. Wealthier families extended the channels beyond the Kang, running them through the walls and under other parts of the floor, creating whole house heating. Imagine an ancient version of radiant floor heating, powered entirely by wood or coal, requiring no pumps, no electricity, no complex controls. Just fire, brick, and physics. When Jesuit missionaries first documented this system in the 1600s, they called it diabolically clever. European engineers didn't develop anything comparable until the 1900s, and even then, they required metal pipes and water boilers. The Chinese did it with clay and stone 1,000 years earlier. 4. The heated wall system. But the Kang was just the beginning. In some regions, particularly in Manchuria, builders took the flue concept even further. They extended the smoke channels vertically, running them through the walls themselves. These heated walls, called huoxiang, turned the entire structure into a heat battery. The same fire that warmed the Kang also warmed the walls, which then radiated heat inward, keeping the room warm from all sides. The result? A thermal envelope so effective that even in -50-degree weather, the interior could stay above 15 degrees Celsius with just 2 cooking fires a day. Here's what makes this extraordinary. The system had no moving parts, no valves, no maintenance requirements. It was entirely passive. And because the walls were made of brick or rammed earth, they had enormous thermal mass, storing heat for hours. Modern radiant wall systems use electric cables or water pipes embedded in drywall, and they require constant energy input. The ancient Chinese version required none. It was a one-time construction cost, then free heating for the life of the building. The twist? When archaeologists excavated ancient homes in Jilin province, they found that some heated wall systems were still functional after 500 years. The channels hadn't collapsed. The bricks hadn't crumbled. It was ancient infrastructure that outlasted empires. 3. The insulated door system. Now, all of this brilliant heat engineering would be useless if the warmth just escaped through the door, right? So the ancient Chinese developed a door system that modern architects are only now rediscovering. Instead of a single door opening directly to the outside, homes had a double-door airlock system. You'd enter through an outer door into a small vestibule, close that door behind you, then open the inner door into the main living space. That vestibule acted as a thermal buffer, preventing cold air from rushing directly into the heated rooms. But here's the genius detail. The outer door was often covered with thick padded curtains made from cotton or felt, adding another layer of insulation. And, in the wealthiest homes, the vestibule itself was heated by a small extension of the Kang flue system, pre-warming anyone entering the house. This is the same principle behind modern passive house design, where airlocks and vestibules are standard. But we act like it's a new invention. The Chinese were doing it when Europe was still building drafty castles with single wooden doors. And there's one more twist. The door frames were recessed into the thick walls, creating a natural cold bridge break. Modern architects use thermal breaks made from plastic or foam. The ancient Chinese used depth and mass. But even the most brilliant architectural design needs the right materials. And this is where ancient China's hidden advantage becomes almost unbelievable. 2. Baijiu lime mortar, the indestructible binder. Imagine a mortar so strong that after 1,000 years, you can't chip it apart with a chisel. This was glutinous rice mortar, and it's one of the most mysterious materials in ancient construction. Builders mixed sticky rice paste with slaked lime, creating a compound that was not only incredibly strong, but also water-resistant and slightly flexible. When it dried, it formed a bond stronger than the bricks it held together. The Great Wall's most durable sections were built with this mortar. Tombs sealed with it remained waterproof for centuries. But here's the thermal secret. Rice mortar had lower thermal conductivity than standard lime mortar. It didn't conduct cold as efficiently, which meant walls built with it stayed warmer. Modern engineers testing ancient structures were baffled by how little heat escaped through the joints. The mortar wasn't just holding the walls together, it was insulating them. And there's a chemical reason for this. The sticky rice created a complex polymer network within the lime matrix, trapping microscopic air bubbles. Those bubbles acted as insulation, the same principle used in modern foam insulation. Except this was organic, biodegradable, and made from food waste. Here's the twist that stunned researchers. In 2010, scientists at Zhejiang University analyzed samples of ancient rice mortar and discovered it could self-heal. When microscopic cracks formed, moisture would activate residual rice starches, which would swell and fill the gaps. It was a self-repairing material created over 1,000 years before scientists even conceptualized the idea. We're only now developing smart concrete that can heal itself using bacteria or polymers. The ancient Chinese did it with rice. 1. The underground heat storage system, the lost art of Dekengli. And now, the system so brilliant, so advanced, that when archaeologists first uncovered it, they thought it was a modern contamination. Welcome to the Dekengli, or sunken courtyard homes, of the Loess Plateau. These weren't built on the surface. They were carved into the earth itself. Imagine standing on flat ground, looking down into a square pit 30 feet deep. At the bottom, you see doorways carved into the walls, leading to cave-like rooms, tunneled horizontally into the surrounding earth. This is a Dekengli village, and some of them housed thousands of people. Here's why this is the ultimate cold weather architecture. The earth itself is a thermal battery. Below the frost line, which in northern China is about 6 feet deep, the ground maintains a constant temperature year-round, around 10 to 15 degrees Celsius. By building homes underground, residents bypassed the extreme surface temperatures entirely. While the air above might swing from -50 in winter to 35 in summer, the underground homes stayed in a narrow, livable range. No heating required in summer, minimal heating required in winter. But the genius goes deeper. The sunken courtyards created a microclimate. During the day, sunlight poured into the courtyard, warming the air and the walls. The thick Loess soil absorbed that heat. At night, the walls radiated it back into the courtyard and the surrounding rooms. And because the courtyard was sheltered from wind, there was no convective heat loss. It was a solar heat trap, engineered without a single equation. Modern earth-sheltered homes are celebrated as cutting-edge sustainable design, but they're just rediscovering what Chinese farmers perfected 2,000 years ago. And here's the final twist. These homes were nearly indestructible. Earthquakes? The flexible loess soil absorbed the shock waves. Fires? There was nothing to burn. Floods? The drainage channels carved into the courtyards diverted water instantly. Some Dikengli homes are still inhabited today, sheltering families who live exactly as their ancestors did. Warm in winter, cool in summer. Paying no heating bills, consuming no electricity. They are living proof that we didn't need fossil fuels or high-tech materials to survive extreme climates. We needed to understand the Earth itself. When Western architects finally studied these homes in the 1980s, they were astonished. Here was a housing system that was passive, sustainable, disaster-resistant, and thermally efficient, built using nothing but shovels and human labor. No concrete, no steel, no glass. Just intelligence applied to dirt. So here's what we've learned. Ancient China didn't survive extreme cold through brute force or endless fuel consumption. They survived through elegant systems that worked with nature, not against it. Rammed earth walls that breathed. Courtyards that controlled airflow. Heated floors and walls that turned every meal into a heating event. Mortars that insulated and self-healed. And homes carved into the earth itself, sheltered by the planet's own thermal mass. And yet, we abandoned almost all of it. We chose glass towers that bleed heat, concrete slabs that freeze, and furnaces that burn money and carbon. We call it progress, but the people shivering in modern apartments during winter blackouts might disagree. The ancient Chinese knew something we've forgotten. The best technology isn't always the newest. Sometimes, it's the oldest. If this hidden chapter of history stunned you, if it made you question what else we've forgotten, then subscribe, because there are countless more stories like this waiting to be uncovered. Lost knowledge that could change how we live today. And the next one might be even more unbelievable.